Hello, now I am going to demonstrate the thermochemical modeling and simulation of chromite reduction process in the submerged arc furnace. So as we can see here that this is the schematic diagram of the submerged arc furnace from inside during the intermediate stage of ongoing process. As we can see here that the arcing is being done using submerged electrodes which are submerged into the pool of already charged material and partially formed slag and also a little bit metal droplets inside it. So in the smelting zone, due to very high temperature, the carbothermic reduction of chromite ore happens, and which results in the formation of liquid metal and slag. So metal also contains carbide, particularly chromium carbide, and slag also contains some solid spinels as well. And by the end of the process, there is an effective separation of slag and metal, so which could be drained once the process is completed. So basically, uh, what we can find on the right hand side is the flow sheet of the process where the input raw materials and output raw materials have been given in terms of their weights and compositions. So as we can see that chromite ore carburizers in the form of mainly coke and flux in the form of cordiite is being added during the process, and the waste gas containing about almost a majority of 70% carbon monoxide is coming out, and slag and metal is being drained out. So almost the equal weight of slag and metal are being produced. So these are the tentative representative compositions of the slag and metal that are being formed during the process. So if we talk about the behavior of this complex process, uh, basically it is it has to be understood fundamentally first of all, and then its behavior could be simulated with the help of a mathematical model. So basically here I tried to simulate it with the help of interconnected reactor based model, which has been demonstrated uh, like the following way, like the way we can see on the screen, that the process has been divided into a number of reactors. The top reactors are the pre-reduction reactors and preheating, where the chromite ore is getting preheated, followed by pre-reduction because of the rising carbon monoxide gases at very high temperature, and then this partially pre-reduced chromite ore is getting into the smelting reactor in the melting zone, where which is in the submerged arc region, where the formation of the metal slag and then separation of slag metal, all these things happens. And basically we have tried to integrate the thermodynamics and kinetics of the process uh, in the form of a flow sheet, which is being represented here, where basically the kinetics of the gas solid reaction has been effectively modeled by using a bypass fraction of the gases which are not able to react with this solid under equilibrium. And basically this process could be run in any thermochemical software in SPin Plus, in FactSage, or in MetSim. Basically I have used FactSage. I had also developed it in the MetSim also as well, but now I'm going to demonstrate this simulation in FactSage by using its macro programming facilities, and I will show that the results are arranged in a well-defined Excel sheet. So So here I'm going to run the simulation. This is the macro programming, and it will take some time. Then after that, the results would be demonstrated in the Excel sheet. So the results will be finally they will be presented in the Excel sheet. Just it will take some time, just a few moments. You have to wait till these simulations are getting over. Since there are a number of equilibrium reactors, they are required to be solved in an iterative manner, and also the reactors are counter-current in nature. So there the mass balance convergence criteria are to be met. So that is why the calculations are being done in the number of iterations till the convergence in terms of heat and mass balance between all interconnected reactors are met effectively. So that is why these simulations are taking a little bit longer time. But the advantage of this simulation is that it is being able to represent a process, such a complex looking process in an effective manner. Uh, so where the operator can understand the behavior of the process under different conditions on the shop floor for different types of the raw material, for different kind of temperature, endpoint temperatures, and so on. So just let the simulation uh, get over, and then after that I will show you the Excel sheet where results are represented in a very beautiful manner. Okay, it is taking a little bit longer time, but it should take a longer time because of the complexity of the problem which I attempted to solve. But of course, it would result in very fruitful outcome. So here we can see that in the Excel sheet, I have represented the same interconnected reactor in the form of a long Excel sheet where the weights and compositions of all the streams are being represented. Also, the degree of metallization which is taking place at individual solid gas reaction based reactor, that has been demonstrated here. And so this is the final outcome that the model is able to predict that around 59% chromium is being resulted in the metal phase, and the metal volume is around 1 ton. So the calculation has been done for 1 ton of the production. For 1 ton, 1.12 tons of slag is being produced, with the silica around 20%, basicity around 1.3, MgO by L23 is around 1.08. I think most of the results are very much closer to what we observe in the industry, but we can. So basically, what we can see from here, that the compositions, weights, and energy consumption of the process could be evaluated very effectively and very much closer to the industry observed results on the shop floor. So basically, if I just yes, energy calculations have also been made, and top gas compositions have also been made. So around 70 to 80% of carbon monoxide in the waste gas, around 3,400 kilowatt hour per ton of energy is being consumed in submerged arc furnace for the case which I have studied. And the effect of various operating parameter change. For example, if you want to make any kind of change in the charge mix, like adding different type of carburizers in different weight ratios, or different kind of flux, or charge, or trying different types of the raw material with different chromium to iron ratio. So all these things could be studied very effectively from this model. So in overall sense, the effect of operating parameters like slag basicity, MgO by Al2O3 ratio, flux additions, carburizer, effect of different type of fluxes could be studied by using this approach. So I am looking forward to have collaboration with the interested industries who are working in this area, as well as research organizations who could benefit through collaborative R&D work in this direction. Thank you very much.